This is going to be a Mechatronics breakdown of the 2016-2017 Baja SAE vehicle. This car possesses a hydraulic braking system that controls the front and rear brakes. It also possesses a CVT transmission that is belt driven and spring and weight adjusted. It has a starting system which has a starter solenoid and ignition coil, and it also has many different sensors to collect data during races. So in the Baja SAE vehicle, the pedal ratio is going to be an important characteristic for the braking system. So the pedal ratio can be simply defined down here as x divided by y, wherein x is the distance from the force that's applied by your foot to the actual pivot of the pedal, and y is going to be the distance from the master cylinder connection to the actual pivot of the pedal. So you can see that as you increase the distance y, as you bring the master cylinders closer to the force from your foot, you're going to actually decrease the pedal ratio. And vice versa, if you bring the force from your foot further and further away from the pedal pivot, you're going to actually increase your pedal ratio. And what this means for the force on the master cylinders and the brake pressure in the lines is that the force from your foot times the pedal ratio is going to give you that force on the master cylinders. So an increased pedal ratio will give you more force on the master cylinders. So with the CVT transmission, there's actually a lot of variables that can be changed to change the outcome or the shifting behaviors of the transmission. So within the secondary, as it's called, there's actually a spring inside of here. So you can change the spring, so you can get a different spring rate. That will change how hard or how quickly these sheaves shift during operation. You can also change the spring preload, so there's a few different holes around here, so you can preload this spring to achieve an even finer graduation in spring rate or force preload. In the primary, there's actually a set of weights that as this rotates, the weights are in here, circular weights. So as this rotates, it will actually force the weights out and shift this sheave inward. So you can change these weights here, and that will determine how quickly it shifts, how far it shifts, different things like that. Okay, I want to give a little rundown on what sensors are actually being used on this vehicle. So first off, we have a shock potentiometer. It's mounted right here, right in front of the shocks. So it stretches the whole span of the shock. And we have those on both right and left front hand side. Another sensor that we have a brake pressure sensor right here mounted in the rear brakes. We've also mounted it in the front brakes as well, just to see what the pressures were in the lines. On the CVT transmission over here, we have a Hall effects sensor. It's mounted into the cover, and it actually traces a magnet that's glued onto the CVT itself. We also have a thermocouple that sits in the cover to measure the ambient air temperature within the CVT cover, and just to make sure the CVT isn't overheating during operation. We also have a thermocouple mounted onto the spark plug here. So this is the spark plug, and then the thermocouple comes right under it, just to maintain or to monitor the engine operating temperatures. So to record all of the signals from the sensors, we have a central hub data acquisition right here. So all the sensors can plug into this. It'll read the analog signals, and then we can translate those into digital data in the computer. This data acquisition system has 3 internal accelerometers for 3 different directions, so we can read that information as well. And it comes with a GPS unit that we can use to map the track, determine location on the track. We can coincide this with the shock potentiometers and read exactly where the shocks we're seeing the most displacement along the track, different data like this.